First gear. To shift into first, we press the clutch pedal to disengage the clutch. Move the gear shift lever into the first position. This causes leakage in transmission. To select the first reverse synchronizer and move its lead locks into the first speed gear. Since the synchronizer is lead are locked to the output shaft, the first gear drives the output shaft when the clutch is engaged. In first gear, there is torque multiplication and speed reduction through the transmission. The main drive gear is smaller than the counter gear it drives. This provides the gear reduction. There is small gear reduction as the small counter gear drives the large first speed gear. The gear reduction can vary. A typical first gear ratio is about 4:1. The crankshaft turns 4 times to turn the output shaft once. There is further gear reduction through the final drive and the rear drive axle. Second gear. To shift into second, the first second synchronizer slip moves to the left. The slip moves through its center of neutral position, unlocking the first speed gear and locking the second speed gear to the output shaft. The second speed gear, driven by the counter gear second gear, now drives the output shaft to the synchronizer slip. There is less gear reduction than in first gear because there is less difference in the size of the gear. Typical gear ratio for second gear is about 2.4:1. The input shaft turns 2.4 times to turn the output shaft once. Third gear. In third, the first second synchronizer slip moves to its neutral position. The third synchronizer slip moves to the right because it measures the third speed gear. The counter gear, third gear, now drives the third speed gear and the output shaft through the synchronizer. A typical gear reduction in third is about 1.5:1. Fourth gear. In fourth, the first synchronizer slip moves to the left so that it meshes with the main drive gear. On the end of the input shaft, the output shaft is now driving the main drive gear through the synchronizer. This is direct drive and the gear ratio is about 1:1. Fifth gear. In fifth, both the first, second synchronizer and third, fourth synchronizer move to neutral. The slip on the fifth synchronizer moves forward. This locks the fifth speed gear to the counter gear. The fifth speed gear now turns the fifth gear, which is explained to the output shaft. Overdrive is provided because the fifth speed gear larger than the gear it drives. Typical overdrive gear ratio is 0.1. The output shaft turns 1 complete revolution while the counter gear turns only 0.8 revolution. Reverse. In reverse, all synchronizer strips are in neutral. The reverse idler slides into the mesh with reverse gear to the output shaft. The counter gear drives the reverse idler gear. It drives the output shaft to the synchronizer slip. The output shaft turns in the reverse direction because the reverse idler gear. A typical reverse gear ratio is about 3.5:1.